So till now we have seen the operation of Hopper rectifier, Fuller rectifier and bridge rectifier. Okay. So in this class we're going to analyze the characteristics of Hopper rectifier circuit. Okay. So coming to today's class, we will see some concepts on Hopper rectifier, right? And we will apply these concepts for Fuller rectifier and also bridge rectifier. Means if you get this concept, you can apply simply to Fuller rectifier and also bridge rectifier. Okay. So అవేంటి అని చూస్తే కనుక see here we're going to analyze the characteristics of rectifier. Based upon these characteristics, we can say which rectifier circuit we have to use for practical applications. So first thing is average DC load. Okay, average DC load current, right? Average DC load current. Simply I call it IDC. Average DC load current. It's also called I average. Right? If I average all the currents which I got at the output, then it is equal to a DC level. Okay, means let us suppose this is the output. Okay, red color waveform is the output waveform. Okay, we are getting instantaneous voltages at t equal to this point. The voltage is at this level. When t equal to this point, then the corresponding output is maximum. Okay, so if I average all this, okay, of course it is also equal to current. Okay, current or voltage. Now I'm talking about current only. Okay, so if I average all these if I average all these voltage current values, then I will get average value. Okay, I will get average value. That average value is this line. Okay, I'll show it with the green color. Okay, this is this line, right? This is the value. Okay, this component is called DC component. This component is called DC component. If it is the voltage, okay, if it is the voltage, then if I average all these values, then I will get DC component of output voltage. Okay, so here see one thing you have to remember is this, that we are taking average value. It gives us DC component. Okay, and I am calling it as IDC. I'm calling it as IDC. Okay, I'm calling it as IDC. IDC means output current. Why? Because at the input of rectifier, okay, these are transformer primary, okay, this is transformer secondary, and this is a diode of a rectifier circuit, and this is a load here. Okay, till this point this is transformer section. Right? Till this point it is a transformer session. Okay, so output of transformer is also AC value. Ante see here, till this point this is transformer session. Okay, from this point From this point, it is rectifier session. Rectifier session. Okay. So till red color boundary, I am with AC voltage only. Now I am talking DC, means అది ఎక్కడ వస్తుంది, అది అవుట్పుట్ దగ్గర వస్తుంది. We'll get this at output. Okay. So output current అన్న average output average current అన్న output DC current అన్న ఒకటే. Okay. So in order to confuse you, exams లో మీకు ఏమంటారంటే అవుట్పుట్ యావరేజ్ కరెంట్ అంటారండి. Output average current means DC current. Okay. Now once you get IDC, you will get VDC. You will get VDC. Okay. Sorry, I am using here small letters. Actually, I have to use big letters. Okay. IDC. I will get VDC here. Since if I get IDC, then easily I will get VDC. Okay. VDC means output DC voltage, means output, at the output of rectifier I will get it. But because DC component is present at the output line only, not input for rectifier. Okay. Now I am analyzing total circuit here, right? So IDC, if I get IDC, I will get VDC. But because this load resistance RL, once if I get IL, so IL means load current. IL means load current. Load current means it is coming at the load. At the load it is DC. At the load it is DC. Okay. So IL or IDC. Once I get IDC, I will get VDC. Why? Because IL into RL gives me VDC. Okay. And now IRMS. I have to find IRMS. Means root mean square value of current. Okay, this is the AC component. Okay, this is the AC component now. Once I get IRMS, I will get VRMS. I will get VRMS. Okay. Once I get IDC, VDC, IRMS, VRMS, easily I can find output power. Output power, PDC I call it. Okay, at the output signal is only DC. So PDC means power at output, means power of the DC signal anamata. So PDC equal to VDC into IDC. Power equal to V into I. VI cos theta. Okay. So phase pakkan unchandi. V into I. PDC. Power equal to V into I. Okay. Or simply I can write IDC square into RL. Because PDC equal to VDC into IDC I can write. PDC into IDC I can write. Or I can write IDC square by RL. Sorry. IDC square into RL. I square R. Power P equal to I square R. Okay. So VD means V equal to I into R. IDC into R. IDC square into R. RL. Load resistance here. So I'll get PDC. Since I am able to find this IRMS, VRMS, I can easily find PAC also. Power AC. Power AC. Okay. Since I'm finding output power and input power, if I make a ratio of this output DC power by input AC power, I will get efficiency. Call at eta. Efficiency. Eta. Eta means efficiency. Okay. IRMS anna IAC anna ఒకటేనండి. IAC anna ఒకటే. VRMS anna VAC anna ఒకటే. Okay, ఇంచుమించుగా. Right? So now I'm finding IDC, VDC, IRMS, VRMS, power DC, power AC, efficiency of rectifier. Okay. And the most important concept I can find ripple factor, gamma, ripple factor. What do you mean by ripple factor? Means how much percentage of AC component is present in output DC. Okay, I have told you that. I have told you that we can't uh, make 100% DC at output. Okay, we can't get 100% DC at the output, right? So there must be some AC component present in output DC. So what is the rectifier circuit for? To convert AC into pulsating DC. If I get pulsating DC, then I will get good amount of DC at the output, right? So rectifier ripple factor means how much AC component is present in the DC component. It is the main point to choose the circuit, which type of circuit you have to choose. Okay, this gives me information about which circuit you have to choose, which should not to choose. Ripple factor. Okay, so after ripple factor, I can find tough transformer utilization factor. How much efficiency of transformer I can able to use in this circuit. This I will get. After that, voltage regulation, VR, we simply write it. VR, voltage regulation. Okay. So these are the 10 uh, characteristics we have to find. First one is IDC. Second one is VDC. If I get IDC, easily I can get VDC. Then IRMS, VRMS. If I get IRMS, easily I will get VRMS. ఈ నాలుగు మీకు కనుక్కోవడం వస్తే ఆటోమేటిక్గా అన్ని మీకు వచ్చేస్తాయి. వై? బికాస్ PDC ఈక్వల్ టు IDC ఇంటూ RL ఆర్ VDC IDC స్క్వేర్ ఇంటూ RL ఆర్ VDC ఇంటూ IDC ఈజీగా వచ్చేస్తుందండి PDC. దెన్ పవర్ AC IRMS స్క్వేర్ ఇంటూ RL ఆర్ VRMS ఇంటూ IDC. Okay, power AC. Then PDC by PAC వస్తే I will get efficiency. Then tough transfer, ripple factor. How much percentage of AC component is present in DC component? This I have to find. Okay. Then tough transfer utilization factor. Then voltage regulation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 concepts we have to learn. Okay, there are 10 derivations, simple derivations, very easy derivations. Okay, of course you will derive it for only IDC into IDC and for IRMS. So if you get these values, then easily you can find all other components values. Okay, is it clear for you? So we are moving on to derivations now, right? First one is average DC load current, IDC. Okay, see here, I am giving see here this step down transformer such that this is the output of transformer. Okay, AC voltage. This is the input for rectifier session. This is the input for rectifier session. This is rectifier session. This is the input for rectifier session. Okay, this is voltage value and this is peak value of voltage. I am calling it as ESM, secondary maximum voltage. If voltage is maximum, current also will become maximum. If voltage is minimum, current becomes minimum. Okay, so If this is the voltage level, then corresponding current is this. Corresponding current is this. Okay, this is the current value. I call it ISM, secondary maximum current. Since input for rectifier is AC, then input current is also in AC. Okay, but see one thing, during positive half cycle of current, okay, during positive half cycle of current, diode is on. Why? Because during positive half cycle, this is the direction of current. Means current enters from anode and leaves from cathode. Okay, so diode is in short circuit manner. So I can assume it with a short circuit. Okay, I can assume it with a short circuit. So current is maximum. Current will become maximum. So I will get maximum current here. This is the value of current during positive half cycle. During negative half cycle, what is happening? Current flows in anti-clockwise direction through diode. Current flows from anti-clockwise direction through diode. Then what happens? Current is flowing from cathode and leaving from anode. Therefore, I can assume diode with the open circuit. Circuit is open. Therefore, current is zero. Current becomes zero in negative half cycle. Means I am since if I take this from 0 to 2 pi. Okay. If I measure it from 0 to 2 pi, sine value 0 to 2 pi, then from 0 to pi, from 0 to pi, I am getting output current. From pi to 2 pi, current is 0. From pi to 2 pi, current is 0. If you observe it. Okay. So only during positive half cycle I am getting current. If if I suppose if I suppose that this is the sinusoidal current, then current I equal to this load current I equal to Im. I can write this as Im sine omega t. Im sine omega t. Since this is a sinusoidal signal, I can write like this: I equal to Im sine omega t, where Im means maximum value of current, ISM. Okay, or Im. Okay, Im sine omega t. This current is called load current, IL. So this load current I am getting from 0 to pi only. Why? Because during positive half cycle only diode is on. During negative half cycle, diode becomes off. So from pi to 2 pi, current I becomes 0. I equal to 0. Okay, this we have to keep in mind. See here, even though current is 0, there is voltage here. There is voltage here. You have to keep this in mind. Voltage is present at the input at the input side in negative half cycle also, but during negative half cycle, current is 0. During negative half cycle, current is 0. Okay, this you have to keep in mind, right? So average DC current. So load current equal to IL equal to Im sin omega t. This load current value is available for me only at the interval 0 to pi. Why? Because during only positive half cycle only I am getting current. During negative half cycle of voltage, current is 0. Means from pi to 2 pi, current is 0. Pi to 2 pi, current becomes 0. Okay, current is 0. Right? So what is the output value of current? This is the output current. This is the output current. Okay. From 0 to pi, I have current. From pi to 2 pi, current is 0. This is output current, IL. Simply called IDC or load current IL, or output current. So what I have to find? DC load value. DC means average value. So I have to sum up. All the voltage levels. Means what I am doing here, I will take this point and I will measure the value of current. I will take this point. I will measure value of current. I will take this point. I will take value of current here. At this point, what is the value of current? I will note. At this point, what is the value of current? I will note. At this point, what is the value of current? I will note. At this point, what is the value of current? I will note. At this point, current is 0. So I will make different segments here on the graph, and I will take different values of current. Okay. So current will increase and decrease. Okay. So I will add all these values. So summation of this all values by number of divisions by n. I will measure at different instants. So at this instant, what is the value of current? I will note plus. At this instant, what is the value of current? This value. I will note plus. At this instant, what is the value of current? I will note. At this instant, what is the value of current? I will note. At this instant, and I will sum up all the values of currents which I have noted down by number of divisions. ఇక్కడ నుంచి ఇక్కడ దాకా 1 2 3 4 5 6 7 8 by 8 వేస్తే నాకు వచ్చేటప్పుడు నాకు యావరేజ్ వాల్యూ. I will get average value. Okay. So this is very tedious procedure to do. Okay. It's very tedious procedure to do. So I'm integrating. Okay. Integration means finding area here. It gives me the average value. Okay. So simply I am giving. So IDC equal to 0 to 2 pi period IL sin omega t d omega t by 1 by 2 pi. 1 by 2 pi means period అనమాట. ఈ పీరియడ్ మనం వేసుకోవాలి, ముందు వేసుకోవాలి కదా. సో 1 by n, 1 by period 0 to n, 0 to total period IL d omega t. But because it is in omega t, I have divided it with omega t. Okay. See here, from this what this how can I write? 1 by 2 pi integral 1 by 2 pi integral, I'll keep bracket here, 0 to pi IL d omega t plus integral pi to 2 pi IL means IL d omega t bracket close. From pi to 2 pi IL is 0, since so this value gets strike off. So 1 by 2 pi integral 0 to pi IL d omega t only remains. So 1 by 2 pi, okay, integral 0 to 2 pi. 2 pi ఉంటుంది, pi ఉంటుంది ఇంకా, why? Because it is 0. IL means Im sin omega t. Im sin omega t d omega t. So 1 by 2 pi integral 0 to pi IL means Im sin omega t d omega t dt. Okay. Therefore, what will happen now? 1 by 2 pi constant. Okay. Im constant. So I have to take it out. So Im by 2 pi integral sin omega t gives me cos omega t. Integral sin omega t gives me cos omega t. Shyam Pratap, what you are doing? So 1 by 2 pi sin integral of sin theta minus cos theta. So minus cos omega t between limit 0 to 2 pi. So upper limit minus lower limit minus cos pi. So I'm taking minus common out. Okay. So minus Im by 2 pi cos pi minus cos 0. Cos pi means minus 1 minus cos 0 becomes 1. Okay. So 1 minus 1 minus 1 minus 2 minus of minus plus 2 to cancel. So I am with Im by pi. I am with Im by pi. So IDC equal to Im by pi. This you have to remember. IDC equal to Im by pi. Im means maximum value of current. Means what? This. Okay. This is the current you are getting now. This is the current you are getting. This is Im. Sorry. This is Im. Maximum value of current. So you don't know maximum value of current, but you know maximum value of voltage. How do you know maximum value of voltage? From turns ratio. From turns ratio, you are getting N2 by N1 equal to ESM by EPM. N2 by N1. See here, I am writing here. I will take another slide. See here, N2 by N1 equal to ESM, maximum value of secondary, by EPM, maximum value of primary. See, N2 means number of turns in secondary. This you know. Why? Because it is constant of a, this is constant for a given transformer. N1 also it is, you know this. Why? Because number of turns of primary winding is constant for a given transformer. ESM, this is what you want to know. EPM is the voltage you are giving. So N2 you know, N1 you know, EPM also you know. So ESM you get to know now. So you will know ESM also. Okay, you know ESM also. So this ESM you know it. This ESM you know it. Pretty much you know it. Okay. This ESM you know it. But from this equation what you are getting, IDC equal to Im by pi. So what about Im? How you can get this Im? Maximum value of current. Maximum voltage of voltage you know. How you know maximum voltage of current? So I have one formula, Ohm's law. V proportional to I. V equal to IR. V equal to IR. So current I equal to V by R. So you want to know maximum value of current. You want to know maximum value of current. So you have to find maximum value of voltage by maximum resistance. By maximum resistance. So ESM or VSM, anything. Okay. ESM or VSM, anything you can write here. ESM, you know. So ESM by R. R means total resistance of circuit. R means here total resistance of circuit. Therefore, Im equal to ESM by RF plus RL plus RS. Okay, this is the total resistance of circuit. So what is RF? What is RL? What is RS? See here, for a given transformer, or for a given half rectifier circuit, okay, for a given circuit, see, I'm going to circuit now. These are windings made up of some wire. So every conductor has some resistance. Of course, the value of resistance is very, very less. Of course, the value of resistance is very, very less. This resistance, I call it RS. RS means secondary coil resistance. Secondary coil resistance. And resistance of diode, I call it RF. RF means forward resistance of diode. Forward resistance of diode. I have some value here. 10 ohms, 15 ohms, 25 ohms, 30 ohms, 100 ohms, 50 ohms, like that. RL, it is a load resistance. Now, since these are connected in series with one another, total resistance becomes RS plus RF plus RL plus RL is the total resistance of circuit, where RS is the source resistance or secondary sorry, it's not source resistance, sorry, secondary coil resistance. Secondary coil resistance means resistance of this coil. RF is the resistance of diode. And RL is the load resistance. RL is the load resistance. If you see, load resistance is in order of kilo ohms. Load resistance is in the order of kilo ohms. RF means forward resistance. It is in the order of some tenths of ohms, maximum 100 ohms, like that. In problem he will give maximum. RS will be very, very less, in order of 10 ohms, 5 ohms, 20 ohms, like this. If you see, secondary coil resistance is much lesser than RF. Okay, so RS means this, RF means this, and RL means this, right? So my total resistance will become RS plus RF plus RL. This I am writing here. This I am writing here. So maximum of current equal to ESM, you know this value. RF, you know this value. Why? Because in problem he will give these values. RL, he will give this value. RS, he will give this value. So RS plus RF plus RL becomes total resistance of circuit. So you get IDC. Once you get IDC, easily you can find VDC, because output DC voltage, EDC, output DC voltage EDC equal to IDC into RL. IDC into RL. Okay. Total current into total resistance. Okay. So what is IDC? Im by pi. Therefore, Im by pi into RL. Im by pi into RL is the total EDC, output DC voltage. Output DC voltage EDC equal to this value you will get. Okay. This I am going to write here in next slide. So IDC equal to Im by pi. IDC equal to Im by pi into RL. Im means just now you have find Im equal to ESM by RF plus RL plus RS. Okay. Therefore, ESM by RF plus RL plus RS into pi into RL. So one thing you have to know here is this, that if you see here, RS and RF are very lesser values when compared to RL. So in the problem, if you don't give RF and RS, take like no problem with that. Okay, even though if we give these values, it is very nearly equal to RL only. Why? Because RL is in order of kilo ohms or in mega ohms. RF and RS are very less values in order of less than 100 ohms. It doesn't affect the value of output voltage much. Therefore, RF plus RL plus RS nearly equal to RL. So RL gets cancelled. RL gets cancelled. Therefore, you get ESM by pi. ESM by pi. Okay, ESM by pi. Right? Now VRMS or IRMS. If you find IRMS, easily you get VRMS. Okay. IRMS means root mean square value. So what is this? If I want to find IRMS equal to root mean means average. Okay, I will tell you later. What you have to find this for? For load curve, you have to find this. So IL square root mean means sum of values by number of values, means integration. So it's called RMS value, root mean square value. So IRMS equal to, what is IL? What is IL? Im square omega t. Sorry, what is IL? Im sin omega t. Im sin omega t. So square for this. So Im sin omega t square. Integral 0 to 2 pi is the limit here. By period is 1 by 2 pi. But I am writing here pi only. Why? Because 0 to pi only have signal. So you can write it 0 to pi plus pi to 2 pi. Plus pi to 2 pi, Im is 0. Therefore, I will get with this value only. Okay. So 1 by 2 pi into 0 to pi Im sin omega t whole square d omega t. So Im square sin square omega t I will get here. Sin square theta. What is the form of sin square theta? 1 minus cos 2 theta by 2. So 1 minus cos 2 theta. Theta means omega t. 1 minus cos 2 omega t by 2. Since Im is constant, I am taking it out. So I will get Im only. Im square becomes Im if you take out of root. 1 by 2 pi, 0 to pi, integral sin square theta means 1 minus cos 2 theta by 2 d omega t. D omega t. Therefore, Im square root of 1 by 2 pi integral 1 d omega t. We get omega t. By 2 is here. So omega t by 2. Minus cos 2 theta. Cos 2 theta. Integral cos 2 theta. Integral cos 2 theta. Sin 2 theta by 2. Okay. Sin 2 theta by 2. Already there is 2 here. 2 into 4. From limits 0 to pi. Therefore, Im root 1 by 2 pi. Okay. If you substitute these values, upper limit minus lower limit. Upper limit pi by 2. Sin 2 pi 0. So pi by 2 minus lower limit 0 to pi to 0. Sin 2 into 0. Sin 0, 0. Okay, we'll get only pi by 2. So pi gets cancelled. 1 by 4. Root of 1 by 4 becomes 1 by 2. So Im by 2. IRM is equal to Im by 2. Okay. Im by 2. This is IRMS. Then what about VRMS? What about VRMS? VRMS equal to IRMS into RL. So Im by 2 into RL. What is Im? Already you found that Im equal to ESM by RS plus RF plus RL. Okay. Now output power. Since output is DC component, to find output power, you have to multiply output voltage, which is DC component, and output current, which is DC component. So PDC equal to EDC into IDC or I square DC into RL. Maximum I will follow this formula, I square DC into RL, right? So I square DC into RL. Okay. So what is IDC? Im by pi. You already found it. IDC equal to Im by pi. You already found it here, right? So Im by pi whole square into RL. So Im square by pi square into RL. What is Im? ESM by RF plus RS plus RL. Substitute this here. Em square RL by pi square into RF plus RL plus RS whole square. Okay, this is a formula. You have to remember this. General is for analysis purpose only. Why? Because RF, RS, RL he will give, ESM, RL he will give, ESM he will give. So no need to find EDC once, IDC once. Again multiply these two, you'll get PDC. Not that. You can substitute this formula directly. Next one is AC input power. Input power means AC power because AC component is present only in the input at most maximum. So power AC equal to AC power equal to you have to use AC component somewhat. See here, one thing you have to note. Here I am using IDC square into RL. Here I have to write. IRMS square into RL only. IRMS square into IRMS square into RL only I have to write. But I am writing RL plus RF plus RS. Why? Output power you will find at output only. At output only. So at the output, total resistance is RL only at the output side. This is for input side. Power AC is for input side. So if you look from the input, see here, if you look from the input, input means here at this side, RS, RF, RL are all resistances here. If you look at from input side, okay, that's why I am writing RS plus RF plus RL. RF plus R, RS plus RF plus RL. Of course, you can use some approximation. Why? Because RF, RL are far lesser than RL. RL is an order of kilo ohms. RF, RS is an order of few ohms here. So you can neglect this RF and RS. If you neglect this, you will be with direct IRMS into RL only. Okay. if you use this formula or if you use this formula, you will get the same answer. But if you use RF and RS also, if you include RF plus RS also to calculate total resistance, then the value which you get will be most accurate one. That's it. So IRMS equal to IM by 2. All you have found it. IRMS equal to IM by 2 here. You already found it. Okay. Substitute here. IRMS equal to IM by 2. So IM by 2 whole square means IM square by 4 into RL plus RF plus RS. Okay. Now efficiency of rectifier. Efficiency of rectifier. Now efficiency of rectifier means the ratio of output DC power by input AC power. అంటే ఇన్పుట్ ఉన్నది మొత్తం ఏసీ పవర్, అవుట్పుట్ ఉన్నది మొత్తం డీసీ పవర్. సో రెక్టిఫై చేస్తోంది ఏసీ డీసీ కింద మారుస్తుంది. ఓకేనండి. ఆఫ్ కోర్స్ ఇట్ ఇస్ ఎ పల్సేటింగ్ డీసీ. ఆఫ్ కోర్స్ ఇట్ ఇస్ ఎ pulsating DC here. Okay. Since it is pulsating DC here, efficiency and దేని డిపెండ్ అయి ఉంటుంది, పెర్ఫార్మెన్స్ పై డిపెండ్ అయి ఉంటుంది. సో ఇప్పుడు ఏం చేస్తున్నాము అంటే ఇన్పుట్ ఒకవేళ మనం ఏసీ ఇస్తే అవుట్పుట్ ఇన్పుట్ పవర్లో ఎంత పార్ట్ని, ఇన్పుట్ పవర్లో ఎంత పర్సంటేజ్ని డీసీ కింద మారుస్తుంది. ఇన్పుట్ ఏమో ఏసీ, అవుట్పుట్ డీసీ. సో ఇన్పుట్ ఉన్న పవర్ని, ఇన్పుట్లో ఉన్న పవర్ని ఎంత పర్సంటేజ్ ఏసీ కింద మార్చగలుగుతోంది సర్క్యూటు అని చెప్పటమే రెక్టిఫైర్ ఎఫిషియన్సీ. So efficiency equal to DC output power by AC input power. So PDC by PAC. What is PDC? What is PDC? You can use any of the formulas, Amma. You can use any of the formulas. Okay. I square DC into RL is the most usual formula. So I into R is the most usual formula. So I square DC into RL means IM square by pi whole pi square. IM by pi whole square into RL. So IM square by pi square into RL. Here I am writing here this. Since I am using IM and RL in this formula, here also I will use that only. So IM square by 4 into RL plus RF plus RS. IM square gets cancelled. Okay, 4 will come up. So 4 by pi square into RL by this value I will get. This value I will get. Okay, see here. So what I am getting here? What I am getting here? Okay, my network was down. Okay, all right. So where I am? I think here I am, right? Network efficiency. So if you see here, I'm getting here 4 by pi square, 4 by pi square